In this unit, we're talking about solutions, and in this video, we're going to be talking about solution stoichiometry. So we know that a solution forms when a solute dissolves in a solvent, and we can describe its concentration in molarity, which represents the amount of stuff, or moles of solute, in a given amount of solution, which we usually measure in liters. So in this solution stoichiometry problem, we're going to approach things the way we have before, except we just have a new way to get to mole town. So in this reaction, we have copper sulfate reacting with sodium hydroxide. These are both aqueous, which means they're dissolved in water. It would look clear if you looked at an aqueous solution. And when you react them, what you're going to get is a solid precipitate that forms in copper hydroxide. And you'll also have some spectator ions in sodium and sulfate that would still be in the solution. So this question asks how many grams of copper hydroxide will be produced from the reaction of 20 mils of 0.25 molar copper sulfate with 30 mils of 0.20 molar sodium hydroxide. So now what we're going to do is we're going to take the molarity equation and we're going to rearrange it to solve for moles. So the number of moles is going to be equal to the molarity times the volume of the solution in liters. So I've taken our volumes for each reactant given and converted them from milliliters to liters, and I also noted the molarity because that's what we're going to use in the equation. So when we multiply the molarity times the volume for the copper sulfate solution, we find that we have 0.0050 moles of the copper sulfate. For the sodium hydroxide, when we do that same process, you multiply them out, you're going to get 0.0060 moles of the sodium hydroxide. Now we need to figure out how much product we could make from each reactant and then pick the lower value because that'll be what we could actually make because we're going to run out of whatever gives us the lower value for the number of moles of product, and then we can use the molar mass to get from that to grams. So for the copper sulfate, that reacts in a 1-to-1 molar ratio with the copper hydroxide. So you get 1 mole of copper hydroxide for every 1 mole of copper sulfate. And so that means that the number of moles we'd be capable of producing from our copper sulfate is 0.0050 moles. From the sodium hydroxide, well, that doesn't react in a 1-to-1 ratio. You're going to get 1 mole of copper hydroxide for every 2 moles of sodium hydroxide. So that means we would only be able to make 0.0030 moles of copper hydroxide from our sodium hydroxide. So that means this would be our limiting reactant, and this would be our excess reactant in this reaction. In another video, we're going to take a look at how we can figure out what the concentration of these ions would be left over in the solution after the fact. But from here, we would say this is the theoretical yield in moles. And if we want to convert that to grams, what we would do is multiply by the molar mass of 97.5 grams per mole. And what we would get is that you could make 0.293 grams of copper hydroxide from our sodium hydroxide. All right, so that's how we would approach stoichiometry from a solutions perspective, rearranging the molarity equation to solve for moles, and still taking our trip to mole town.